Hello Linux fans. In my last video we discussed permissions and special permissions. What I would like to do now is to demonstrate some of these things that we talked about from the command line point of view. So I have Linux Mint Cinnamon 18.3 up and running, and this is the GUI. This is the Cinnamon desktop. And what I'm going to do to demonstrate the command mode and how permissions work in the command line environment with a CLI command line interface, I'm going to open up a terminal. So we'll open up our terminal and we'll maximize the terminal just so that you could see things a little bit better. You see that we're in our home directory because of the tilde, and we're a regular user because of our $sign. So the way that we see our permissions is we issue the command ls space -l. And as I mentioned, that is a lowercase l. We hit enter, and what we see here is a long list directory of our home directory for user tech, which is my demonstration user right here. These are basically the permissions right along here. Okay, these right here. And you see this D right here. Okay, this row of D's in the first row here. Those are for directories. In other words, the way we're looking at it now, and like I said, this is a clean install here in a virtual box. There aren't any separate files in a home directory. They're all directories. There are no individual files in our home directory. There's only subdirectories within the home directory. And because this is a clean install, everything is at its default. So we get a good look at what the default permissions are for a clean install of, in this case, Linux Mint Cinnamon 18.3. And you see you have directories. Okay, this is for the owner right here. Okay, and you see here RWX. That means read, write, and execute. So this octet would be the 7. It would be 111. If we looked at the octal numeric notation for this, it would be 111, which would be a decimal 7, meaning that the owner tech, in this case, has read, write, and execute privileges. Okay, this second here, if I can get it to cooperate with me to highlight it, you see an R, a dash, and an X. This, as we mentioned, is for the group. Okay, the group that tech would be in. And you see they have read and execute. They do not have write, which means they can read a file that tech puts out there. They can execute either a script or an executable or some other type of file that actually does something. They can execute what it does, but they can't write to it because this right here, I can't get it to hide. This right here is a dash. There's no W there. So we have read, dash, and execute. So that's the group. This third section right here, we see the same thing, R-X. So that would basically be everybody else. So the way this machine is set up and the way Linux Mint Cinnamon 18.3 defaults when you do a clean install is the owner has read, write, and execute privileges, which you would expect. They're the owner. You would expect them to have full access. Their group has read and execute, but not write. And everybody else has read and execute, but nothing else. That can be changed using the various commands that we learned on the other slide. This line here, this 2, we're not going to cover that too much in this demonstration. That's the number of hard links that are associated with that particular file or directory. In this case, that's a whole other topic. This tech here is, of course, the user or the creator of the file. Okay, this other tech here, that's in the position of the group name. Now, it's important to keep in mind when you create a user, you create a group for that user. And in the beginning, the only user in that group is the owner. That can be changed by other options later on. But when you use the user add and other utility commands, which are discussed separately, when you do a clean install, every user has a user group that in the beginning, at least, they're the only user in. You have a file or a directory size right there. In this case, it's 4096 bytes. Okay, they're all the same byte count here. You have your date stamp right here. In this case, it's September 3rd, 2017. That's the date I actually created this install. I actually did the install. And then this is either the file or the directory name. In this case, it's the directory desktop, directory documents, directory downloads, etc. You notice they all have the same date because they were all installed on the same date, the day I created this virtual machine. To show you how to change things, okay, let's go into one of these subdirectories here. Okay, let's go into, these are all going to be empty initially, so let's go up a level, and we know that bin, okay, that's the binary, that's our executables. So we issue the command cd space /bin, enter, and that takes us to the bin subdirectory, as you see here. That's a level up from the home directory. If we issue the command again, ls space dash lowercase l, we see, and we can scroll because we're in a terminal, not a TTY, we see these are all the files and their permissions, and there's different colors which we will explain a little bit about in a little bit. But we see these permissions here, and for our executables, for the defaults, okay, you see these aren't directories, okay, there's a dash in this first space right here. It won't want to highlight, but right here, right where I'm moving my cursor, is a dash. That means it's a regular file. Then we see the permissions right here, owner, read, write, execute, which again we'd expect. The group is read and execute, which we'd expect, and everybody else in this case is also our read and execute. So the permissions are basically the same as in the home directory. We have the number of hard links, which is 1. Okay, only in this case you notice the user and the user group are both root here. You have your byte count, which is a different size because this is an actual file, and of course the date is whatever date this executable was released and finalized from the repository. It's not the date it was installed because it wasn't modified on that date. It was simply copied over. So the date timestamp wasn't done. Then you have the file name over here. Okay. We can change these commands, and for the purposes of ease, I'm going to use this znew command here. And I'm going to show you, let's say we wanted to take read privileges away from everybody else. Okay, we would type in, okay, chmod for change mode or change mod, space, okay. Our option in this case, you could do it either symbolically or with symbols. Okay, I'm going to do an O for other minus because I'm going to take away read, and R for read. And you have the file name, which for purposes of demonstration is going to be ZNEW right there. You hit enter, and you see that it says operation not permitted right here. Okay, the reason for that is because remember, we're up a level from the home directory. We're in the administrative section. So I wanted to point out the fact that for this we need the sudo command, superuser-do. So we type in sudo, superuser-do, SUDO, space chmod, okay, O minus R, and the file Z new. We hit enter. It asks for our password, which in this case is, I'll enter that here. You notice it does not print out or type out for security reasons. You don't even get any dots or anything, because that would give a hint as to how many characters it is. You just get nothing. And we don't get an error message, so we know that it did it, because in Linux, if you don't get an error message, it usually means it did it. Now we'll type in our ls space dash l lowercase, and you see now how we have read write execute for owner. We have read and execute for the group. You notice how we no longer have r/x like we do up here. We now have dash dash x. We have effectively taken away read privileges from everybody else by using the change mode command. We can do the same thing if we want to put it back again. Okay, again, we need sudo because it's an administrative command. Okay, sudo space, then you put your chmod space, your option, which in this case you're giving other plus x, r, excuse me, because you're giving read privileges back, and the file is going to be znew, Z-N-E-W. We hit enter, and it did it. It remembered our password, because the way Linux Mint is written, if you put in the sudo password, it does remember it for like 5 minutes, and then you have to re-enter it every time after that. But you see it did it because no error message. So if we type in ls space dash l, okay, we see here that our read is now back. So that's an example of how the change mod works. One last thing I want to talk about in discussing the sticky bit. Okay, the sticky bit we discussed in a previous video is something that can give privileges to other users that the owner would have. I want to show you what that looks like. The use for that would be if, let's say, you want to give everybody rights to execute a file. And right here, the way to tell something with the sticky bit set in this particular distro is you see how everything is kind of light green. These are administrative functions. You really need administrative privileges, let's say, to do that, or you would have to have an X here to have the permission set. But unlike, let's say, zcat here, where you have RWX for read, write, and execute on the owner, if you go to unmount, you want everyone on the system, everyone, to be able to unmount whatever device they mount. So if we come over here to the owner's permissions, you notice here, okay, instead of an X for execute, you see an S. That's an example of that sticky bit we talked about, which is a special permission. There's a few of those. We're not going to get into all of them in this video, but I do want to mention the sticky bit because this S here would imply that the user, all users, would be able to execute this file just like they would if they were the owner. And a good example that I do want to show you, which is interesting, let's say we issue the command sudo because we need administrative rights. And what I'm going to do is I'm going to take execute privileges away from the group and everyone. So what I'm going to do is I'm going to put change mod space, and then I'm going to put minus, okay, and what I'm going to be taking away is execute, so that it's minus X, hold on, I'm going to backspace it. Okay, I'm going to do, for the groups, I'm going to do G for group and O for other minus X, and I'm going to do that with the file umount. So what I have is sudo change mod group and other -X, take away execution, and I'm going to do it to the file umount. I hit enter. It did it. It still remembers my sudo password. So now let me do my ls space -l again, and you notice up here now the X is gone, but this S is still here. Okay, these other users are still going to have privileges because of this S. This sticky bit sort of implies that executable privileges remain even without being explicitly mentioned. That's the same up here with ping. You see ping has its sticky bit set, and ping 6 for the TCP ICP 6 version, and umount is for unmount, SU for super user. Okay, you see this NTFS3G, and notice all these system commands. Mount is another one. Okay, all these reds are the ones that have the sticky bit set. So I just wanted to make you aware of that. If we wanted to change that back, we could type in sudo. Okay, and then we have change mod again, and we have G for group, O for other. We type in plus because we're adding execute privileges for the file umount. We hit enter. It remembered our sudo password still. We're still within the window for when I entered it. Okay, ls space -l. And we go up to umount, and we see that our X's are back. Our sticky bit is still set, so everything is as it was. So that is a little bit of a command line demonstration of how we can use permissions for administrative purposes within a terminal. Thank you everyone for watching.